Okay. Hello, everybody. We are starting our TASMO live stream soon. So let's wait for 2 more minutes for everyone to join. Okay, in the meantime, please get your completed paper ready. Okay, I'm also adjusting my seat as well. Oh, that's me. Okay. All right, let's wait for 1 more minute for more of your friends to join, and then we can start our live stream at 5:30. Hi, hello. Okay, I see some familiar names here. Okay, welcome everyone. So let's wait for around less than a minute. Okay, I will start at 5:30. Oh, which is in a few seconds. All right, everybody. So let's get started. Okay, long time no see, everyone. Hopefully, everyone has been doing well after the TASMO prep. So once again, we are meeting each other again, right? Because it's TASMO season now, and we are starting off with the sample paper 1 analysis today, right? I've received a lot of submissions from the kids, and I really would like to comment on everyone's effort and dedication. Okay, so first of all, for kids who are new here, let me introduce myself, right? You might be wondering, who is this teacher on the screen, right? It's me, I'm teacher Yong Lam. I am a P2 teacher in Think Academy. So yeah, nice to meet you all. Okay, so a warm reminder for everyone here, right? If you have not yet registered for P2 TASMO 2025, please scan the QR code in the screen, right, to register, right? It's on the 13th of September, which is a Saturday, from 9 a.m. to 10:30 a.m. So in the morning session, right? We have 3 locations available. They are our Tyson Center, Marine Parade Center, as well as Buona Vista. Okay, and the difficulty level is around P2 to P3 SASMO. Right, so this is our first of 5 live streams, okay, that are available for everyone to prep for TASMO together. So I will be sharing a sample paper every week. We work through the problems and then meet on every Tuesday at this timing. Okay, and yeah, a round of applause to a lot of students who have submitted their TASMO sample paper 1, right? I have noticed that after these children, right, there are also several children who have submitted as well. So kudos to everyone. Yeah, please keep up the good work. And thanks to your submissions, I'm able to figure out what are the challenging problems for today. So I would like to go through them now. And yeah, for now, please get ready with me your completed sample paper, as well as some stationery items for your corrections or taking notes. And most importantly, please maintain a good mood, a smiling face. Let's get through this together. All right. So without further ado, here is a list of the challenging questions that I will be going through for today. Right, 3 from section A and 5 from section B, right? And hint, hint to my MHA and CO students, okay, some of them involve some topics that you will learn in the upcoming few weeks. So just a sneak peek about what's going to happen in class soon. All right, without further ado, let's start off with a very confusing question in section A, right? This question is question 10, and let's read the question together. All right, so in a treasure hunt, there are 9 hidden chests and 9 distinct keys, right? So we have 9 chests and 9 keys. Each key unlocks a specific chest, and no 2 keys can unlock the same chest, right? So that means the chests and the keys, there will be a 1-to-1 matching. Only 1 key can open each chest. Now, what is the greatest number of attempts Sam needs to make to discover which key corresponds to each chest? Now, this discover is the keyword to this question, right? Which causes a lot of confusion, and I am here to tell you what's the meaning of discover, right? But before that, hey, I see a red number over here, 14.3%. What does that mean, right? That means out of 100 students, only 14 of them managed to get this question correctly, right? Which is why I think this question is definitely what I should start with. All right, so without further ado, let's take a look at what exactly this question is talking about. But first, we have a little warm-up, right? So imagine there are not 9 chests, but only 3 chests, right? And 3 chests, 3 keys. My question is, let's say you are trying to open them, right? You have to give the keys a try one by one into each chest. And let's say you are very unlucky. Okay, you are the unluckiest person in the world. At most, how many tries do you need to open every chest? Right. So you might want to try one by one, starting from the first chest. Let's discover, right? How many tries do you need at most to open this chest? Think about it. You have 3 keys. If you are very, very, very unlucky, okay, how many tries do you need to open this chest? Think about it. Why? Why? How many? Do you think 1 is enough? But you are unlucky, right? Maybe you would want to try the first key and you realize, hey, it doesn't work. Then you would want to try the second key and then you realize it doesn't work again, right? I haven't opened the chest. So if you are very, very unlucky, you would need 3 tries to open the chest, right? The first 2 keys you realize, I cannot. Then only the last key would work. Okay, so therefore, right after 3 tries, you have selected a key and opened the chest, which means now you need to move on to the second chest. Now, as you move on to the second chest, how many tries do you need at most to open this chest? Do you think you will still need 3 keys? Right, let's look at the chat. Do you think you will still need 3 keys? Some people say, yeah, I still need 3 keys. But think about it. You guys are unlucky, but you guys are smart. If the third key opened the first chest just now, would you still try it on the second chest? Of course it wouldn't, right? We know it already belongs to another chest, so I don't need to touch it, which means only 2 keys are remaining. And if you are very unlucky, you will need to try both of these keys, right? Key 1 and key 2, before you can open the chest finally. Okay, so yeah, like what some of you have said in the chat, you need 2 tries to open this chest. Now, what about the last chest? How many more tries do you need? Now, you already found out the 2 keys for the previous 2 chests, which means you only have the last key left. To open this chest, you just need to try this key onto the final chest. So 1 more try. So altogether, 3 chests, 3 plus 2 plus 1 equals 6. You need 6 tries altogether to open every chest. Now, so if you are asking how many times you need to open every chest, then for every chest, it equals to the number of keys available. Available as in you haven't used this key to find out which chest it belongs yet, right? So 3 plus 2 plus 1. Now, the question, however, is not asking how many times you need to open every chest. It's asking how many tries to discover the key to every chest. Now, what does the word discover mean? Discover means, aha, I realized how many, or rather, which key is needed for every chest. I realize, do I really need to open every chest? I don't need to. I just need to realize that the key belongs to the chest. I don't need to open it. All right. So with that, let's try again. How many tries do I need to discover the chest? Do I need 3 keys now? I don't. Right, let's say I failed for the first key. I failed for the second key. By the time I failed all but 1 key, I would have already realized, I need this key to open the chest. I would have discovered it, right? I would have realized it. Do I need to open it? I don't need to open it, right? So actually, 2 tries are needed to discover which key matches the chest. Now, let's move on to the next chest. Now, what do you think? For the second chest, how many tries do you need to discover the key for this chest? At most, if you are very unlucky. If you are very unlucky, there are 2 keys remaining, right? You might try the first key and you realize, yeah, cannot, right? But the moment you realize the first key is not correct, you would have already discovered, you have already realized, right? This remaining key is what you need for the second chest. So, yeah, you need 1 more try. And at this point, you already matched 2 of the keys to 2 of the chests. How many more tries do you need to discover for this chest? Do you need to try again before you realize, okay, I know which key is to which chest? Well, you only have 1 more key and 1 more chest left, right? These are the remaining keys and chests. You don't need to try again, actually. You have already realized, the last key is for the last chest, right? So you will realize that in this question, I need to only know which key is for which chest. I don't need to open it. So the tries I need at most is equal to the keys available minus 1, right? Which is why I will have 2 plus 1 plus 0 instead, which is 3. So I need 3 tries only to discover, okay? So that's the distinction between opening and discovering, right? Hopefully this is made clear now. But now in the question, we have 9 chests and 9 keys. And we want to find out how many tries we need at most to discover, which means for the first chest, right? For the first chest, how many tries do we need? Do we need 9 tries? What number should I start with? 9 chests, right? Discover. Do I really need 9 tries? No, I just need 8 tries, right? The first 8 keys. If I try the first 8 keys and I realize, oh, very unlucky, I failed for all of them, then I would have already realized, already discovered the last key will work. Right? So I don't need to try. I just need to realize it. Okay, so then 8 is for the first test, second test, 7, 6, 5, 4, 3, 2, 1, 0. And if you add them up, you get the answer 36. So my answer is E, none of the above. Right, this question is pretty tricky because a lot of you would see B, right? 9 plus 8 plus until 1 and chose that answer. Okay, but actually, you need to realize how to understand each question thoroughly. Okay, and that is how to attempt this question. Now, without further ado, let's move on to the next part. Okay, now the next part is about calendar problems, right? My MHA kids, are you here? Right, this lesson will be lesson 9 of our MHA course syllabus, and it's asking, right, if 23rd August is a Friday, which day of the week is 28th May of the same year? Okay, now I see that about half of you got it correct. Very good. For the other half, please take note, right? This is also very common in P2 or P3 TASMO questions. So maybe you might think, yes, I'm a pro in understanding the calendar, right? I can memorize the days and I can just count one by one. But there's actually faster ways, right? For that, let's take a look at the little warm-up over here. So this month is July, right? So let's see. What if I want to count how many days are there from 10th July to 20th July? How many days are there in total? Is it just 20 minus 10? Okay, but if you count one by one, you will realize it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 days in total. 11 days in total. But then 20 minus 10 is just 10. Can I just do 20 minus 10? What should I do after I do 20 minus 10? Right, I will need to plus 1. The moment I do 20 minus 10, I am taking the first 20 days and I'm removing the first 10 days from it. I am removing the first 10 days from it. But I want the first 10 days. I want to keep, or rather, I want to keep the 10th day, right? I remove the first 10 days from the first 20 days, but I want to keep day number 10. So I need to add back day number 10, which means I need to plus 1, right? So that will give me 11 days in total. I will need 11 days in total from 10th to 20th July. That's 4 days in total. Now let's change the question a bit. How many days later are there from 10th July to 20th July? I start from 10th July. I'm asking you, how many days later is 20th of July? Right. So then you just need to jump 1 day later, 2 days later, 3, 4, 5, 6, 7, 8, 9, and oh, teacher Yung missed the point, right? 1 day later, 2 days later, 3 days later, 4 days later, 5 days later, 6 days later, 7, 8, 9, 10, 10 days later. And in this scenario, we are just taking the end to minus the start, right? For both my MHA and CO kids, we have learned about interval problems. It's about the same thing, right? So when the question is asking how many days later, you just see how many intervals are there between the days. So you just take the end minus the start. All right, so this is for if it's the same month. But however, if it's different months, then can I just say, aha, I know 16 minus 7, right? For example, 16th July to 7th September. I can't just say it's 9 days later, right? I am going across different months. So instead, we have to jump one month by another. Okay, so for example, 16th July. Let's move on to 31st July. How many days later is it? That would be end minus start, 31 minus 16, 15 days. Then I move on to August. To move on to August, I need to move 1 more day later, right? 1 day later from 31st July, it's August. Then I go to the end of the August because I'm ending at September, right? From the 1st August to 31st August, that's another 30 days later because 31 minus 1, right? This is 31 minus 16. And then now I want to move on to September, right? First, I need 1 day to move on to September. And then now from the 1st September to the 7th September, how many days later is it? Right, you can just take the end minus the start. 7 minus 1 equals 6. So it's the 6th days later. So altogether, you can add up to find out how many days later are there. Right? So how many days later are there? 15 plus 1 plus 30 plus 1 plus 6. However, this is a lot to write down, right? So let's observe the calendar. Mainly, let's observe from 31st July to 31st August. Let's say that I want to start from 31st July and I want to end at 31st August. How many days later will that be? Right? So I do not include the start. I just jump to 1 August. 2, 3, 4, 5, 6, so on and so forth to 31. So if I ignore the start, right, in days later, I just count the jumps. Then I just need to go through 31 days later to go to 31st August. Right, 1 day later plus 30 days later. So it's 31 days later. Likewise, from the 31st August to the 7th September, that's just 7 days later, right? From the end of August to whichever day I'm on in September, that's just 7 days later because it's the 7th of September. So can anyone tell me how many days later is it altogether? Right? Yeah, I see. Can see already said, oh, it's 53 days later, right? 15 plus 31 plus 7. That's 53 days later. All right. But then let's go through one more reminder. Now, from 5th August to 6th August, that's 1 day later, right? Now, if I change the question, how many days ago is 5th August compared to 6th August? How many days ago it is? It is also 1 day ago, right? Likewise, 5th August to 17th August, that's 17 minus 5, 12 days later. How many days ago is it? How many days ago is it? It is also 12 days ago. So whenever you see a days ago question, you can just count how many days ago, similarly to how many days later, right? So just change it to counting the days later. So with that, let's take a look at the question again, right? The 23rd August is a Friday. Which day is 28th May? So we are working backwards, right? We are finding the day of a week for a day in the past. We are working in the ago direction. So maybe we can change it to days later first, right? Counting how many days ago is the same as counting how many days later in the opposite direction, right? 1 day ago is Monday, right? Then from Monday, 1 day later is Tuesday. So let's count how many days ago, which is essentially the same as counting how many days later. So let's start off from our starting date, which is 28th May. And remember, we go to the end of the month first, right? We go to the end of the month. From the 28th May to 31st May, how many days have passed? How many days later is it? That's 3 days later. So I plus 3, right? Because it's 31 minus 28. Then remember, we want to end at August, which means I need to go through June and July as well. So let's look at the ending date of June. From the end of May to the end of June. Now, if you are starting from the end of a month and going into the next month, how many days later are there? You just take whichever number is at the second month, right? From the end of May to the 30th of June, that's 30 days later, right? This holds true when you are starting from the end of the month to some day of the next month. So likewise, from the end of the June to the end of the July, which is 31st July, end of the June to end of July, how many days later is that? You just need to look at 31st here. So plus 31. All right. And finally, can anyone tell me from 31st of July, which is the end of July, to 23rd August, how many days later is that? And now at 23rd August, right? From the end of July to 23rd August, how many days later is that? That's right. Very good job. That's 23 days later. Yes, good job. Right. So with that, we have successfully segmented the months and found out how many days later are there. 23. That will be 87 days. But remember, we are using this diagram to help us count how many days later are there, how many intervals are there. But the question is asking for the day of the week, of a day before what's given, right? We are going towards the past. So this is actually 87 days ago, right? We are working towards the past. Starting from August, we want to look how many days ago is this date, right? Just that moving forward is easier for us to count, which means now we need to find out what is the day of the week 87 days ago. Today is a Friday, 87 days ago. Do you really want to count one by one? 1, 2, 3, 4, 5? No, right? Because you remember, every how many days ago we go back to a Friday? Every how many days ago do we go back to a Friday? How many days ago? Right. If today is a Friday, how many days ago is another Friday? Right. That's just 1 week ago, right? So 1 week is 7 days ago. Every 7 days ago, we go back to a Friday. So it's a cyclic pattern. It keeps on repeating, right? So 87 days, I can just group them 7 by 7 because every 7 days, I'm back to the same Friday. Every 7 days, right? And 87 divided by 7 is 12 remainder 3. Now, this 12 means we have gone through 12 full weeks, right? 7, 7, 7, 7. We have gone through 12 full weeks. And now my next question to you. Remainder 3 over here. Does it mean we have 3 more days ago or 3 more days later? Is it A or B? Right? Yeah, you will notice that the question is going backwards, right? It's going to the past. And we already noted it's ago. So remainder 3 means 3 days ago from Friday. So starting from Friday, I just need to go back 3 days ago. So Friday, 1 day ago, it's a Thursday. 2 days ago, Wednesday. 3 days ago, Tuesday, right? Friday, Thursday, Wednesday, Tuesday. Remember, we are working backwards because we are finding days ago, right? So my answer is A, Tuesday. And that's how you get the answer. All right? So yeah, this is just a sneak peek into how evil calendar problems can be, right? So hopefully now you understand this problem. In sample paper 2, I think there will also be a calendar problem as well. So please keep a lookout on that. All right. And with that, question 15 is our next problem, right? With 35% of you getting correct. Now we have 4 sheep and a black wolf competing in a 400-meter dash, and they now are sharing about their placings. If only the black wolf is lying, which place is sheep A? Right, so let's zoom into this question. Okay, what is special about this question? There are 4 sheep, A, B, C, D, and a wolf. Now, the key point here is only the black wolf is lying. Okay, so with that, the first step is definitely to find the special liar. If there's only one person that is special, right, we try to find out what that person is or which person is that special person. Only one person telling lies. Who is telling the lie? Okay, so what do you notice? Actually, it's a bit difficult, right? Everyone could be the wolf until you realize there is a sus person. Now, let me ask you, can Teacher Yong Lam say Teacher Yong Lam is older than Teacher Yong Lam? Can Teacher Yong Lam say I am older than Teacher Yong Lam? Or I am a neighbor with Teacher Yong Lam? Can I? No, right? I will never refer myself with my own name in the same sentence, right? So who is addressing the black wolf and itself, right? Who must not be the wolf here? Do you see someone who is calling the black wolf and also calling himself? Right. Oh, not Z. Oh, it's a typo already. Now, yeah, someone mentioned that the third place said, I am faster than the black wolf. So can this be the black wolf? Black wolf said black wolf is faster than black wolf. Doesn't make sense, right? So this cannot be the black wolf because he is referring himself with the black wolf together. So this is definitely not the black wolf. And remember, since this is not the black wolf, he must be telling the truth, right? Which means I don't only eliminate 3 as the black wolf. Since 3, or rather the third place, is faster than the black wolf must be behind the third place as well, right? And who is behind? 4th or 5th, right? Which means the first and the second place is also not the black wolf. The black wolf could only be the 4th and the 5th place among them. And hey, do you notice between the 4th and the 5th place, someone else is also addressing the black wolf in 3rd person, right? Who is it? Who is it? The 5th place said, sheep D is faster than the black wolf. He's mentioning the black wolf in 3rd person view again. So could he be the black wolf? No, he can't, right? He is not the black wolf as well. Otherwise, he wouldn't say the black wolf, right? He would say me. Okay, so with that, the wolf must be at which place? It's not the 3rd place. It couldn't be faster than the 3rd place. It's not the 5th place. So the wolf is at the 4th place. Right? We already located now. The 4th place is the wolf. Right? The 4th place is the wolf. Now, why is finding the wolf so special and so important? Because remember, what is special about the black wolf? Is the black wolf an honest person or an honest animal? No, it's not, right? The black wolf is lying. Since we already know the 4th place is the wolf, that means whatever the 4th place says is wrong. And we have to switch it to the truth, right? So whatever the 4th place is saying, sheep A is faster than sheep B, remember, it's telling a lie and you need to change it, right? So if sheep A is not faster, that means sheep A must be slower, right? Sheep A is faster. That's a lie. So sheep A is actually slower. So we change the lie to the truth. And now, after I make this change, everyone is saying the truth now. So it's time to compare and arrange every contestant, right? Now, with this, I want to remind all of you, right? I've said this before, especially for my NHA kids, when we are doing logical reasoning, right, and we are comparing who is faster, who is slower, we will use a magic arrow and locate or arrange the different items, right? So here, everyone has a placing, right? For first place, second place, third place, 4th place, 5th place. So we assign them the placings, assign them the seats. Okay, and which animal has the placing that we definitely know? We talked about it just now, right? Which placing do we know? Right. Oh, everybody already said, right? Just now we talked about it. The wolf is the fourth place. So the fourth place is the wolf. And now I just need to arrange the other people, right? Who is faster, who is slower. Now, with that, let's try to look for which animal appeared the most number of times. Maybe you can focus on sheep D, right? Because sheep D appeared twice in this scenario. The first time is when the second place said, I am faster than sheep D. Now, second place is faster than the sheep D, which means should sheep D be ahead of the second place or behind the second place? Should sheep D be ahead of the second place or behind the second place? Right? A for ahead, B for behind. Right? Second place is faster than sheep D, so sheep D is behind, which means this is the second place. Sheep D could be here, sheep D could be here. Right? But then someone else mentioned something about sheep D, right? The fifth place say sheep D is faster than the black wolf. Now, first of all, the fifth place cannot be sheep D, right? Otherwise, he wouldn't be referring to sheep D as the third person view, right? The fifth place would say I am faster, or rather I am slower. So definitely not. And also, D is faster than the black wolf, which means D must be in front of the black wolf. So if it is in front of the black wolf and behind the second place, then D must be at the third place, right? Behind the second place, in front of the wolf, D must be the third place. Okay, now we fixed D's position. Now we still have A, B, C left, but no worries. Look at what the first and the fourth place say, right? They all are talking about A, B, C. Let's read them together. Sheep A ran faster than sheep C. Now, this is a truth, remember, because whatever the wolf said is already changed into a truth, so we don't need to worry about the other statements. Sheep A is faster. So A is faster than C. And then another sheep said, A is slower than B. Oh, this is what the wolf said, but we change it to a truth. So A is actually slower than B, right? So A is behind B. Now we already know the relative positions of A, B, C. We just fill them in according to the order in the main magic. B, A, C, and aha, you would realize we already found the answer. So what placing is A? A must be the second place, right? Someone said place is saying I am faster than the black wolf. Exactly, right? The third place say I'm faster than the black wolf. So yeah, that's how we figure out the black wolf situation. So whenever you see a truth and lie situation here, remember to first find out who is the liar or who is telling the truth. Then change all the lies to truths before you try to really look at each sentence and compare, arrange their placings. All right, so this is the logical reasoning problem, and hopefully this is a useful explanation for you. Okay, now we are done with section A. Let's move on to section B. And at this point, I want to give a shout out to my CO kids, okay, because the next question is related to that, right? Only 33.3% of you answered this question correctly, but it's actually pretty easy, right? There are how many ways to make a 4-digit number without repeating digits using 6 digits, 2, 3, 4, 5, 6, and 7. So we want to choose 4 out of these digits to make a 4-digit number without any repeating digits. How many ways are there? Now, I believe, right, if you haven't learned addition and multiplication principles left, you would want to list down one by one. And you would list until tomorrow, and then you haven't finished, right? Or you might think, oh, teacher, I have learned dictionary arrangement method before. Now, that is useful when the numbers are small. But now, I am making a 4-digit number, and I'm given a lot of choices. We need more sophisticated methods for this, which is the addition and multiplication principles, right? So let's go through a little warm-up first, right? Let's say I am giving you 4 digits, 5, 8, 9, and 6. I ask you, how many different 4-digit numbers you can form if you use only once for each digit? So maybe you can think of them as people, right? There are 4 people, and you arrange them into the seats one by one. How many choices can you make for the first thousands digit? You want to choose one digit for the thousands? There are 4 digits for you to choose. So you can choose you can make how many choices for the first thousands digit. Oh, Sicheng, don't understand what. Okay, is it the previous question? It's okay, right? I will send the full solutions later. But now, 4 digits are given to you. You want to choose 1 for the thousands place. Okay, so that is 4 choices for the thousands place. Now I have chosen 1 for the thousands place, which means I cannot repeat it in the subsequent digits. Let's say 4 thousands. Okay, four digits for the thousands place. I chose 5 as my thousands. How many choices are left for my hundreds place? 1, 2, 3. Right, only 3 choices for the hundreds place. And I chose another one. Then how many choices for my tens? 2 choices left. Choose another one. 1 choice left for my ones place. Right, which means, right, you notice that as I keep on choosing the digits one by one, if I cannot repeat the digits, for every place value, I will only have fewer and fewer choices. Then finally, right, 4 for the thousands. For every of the 4 choices of the thousands, I can choose the hundreds in 3 ways. For every 3 ways, I can choose the tens in 2 ways. For every way to choose the tens, yeah, there's only one way to choose the ones. So finally, we will multiply all the numbers of choices together and get the total number of 4-digit numbers you can make. Right, so this is what we call the multiplication principle, right? We list down each place value one by one, find out how many choices there are, and then we multiply the number of choices. Now, let me switch the question a bit. What if we can use the digits above more than once, right? I can repeat the digits. Again, I need to choose 1 digit for the thousands place, and I have 4 choices, so definitely 4. But once I choose one of the digits for the thousands, can I still choose it for the hundreds? I still can, right? I can repeat them. So I still have the same 4 choices for the hundreds, and I can choose one of them, right? So 4. Same 4 choices for the tens, same 4 choices for the ones, right? I can choose 1 out of 4. Then finally, we can multiply them all together. And what does this give us? Right, 256 ways. Okay, so yeah, when you realize that you can repeat, then in every seat, in every digit, the choices are always available. Okay, the choices are always available. Now, with that, let's take a look at this question. Okay, now this time, I want to make a 4-digit number using 6 of the digits. Using 6 of the digits. So we want to list out all the digits and consider them one by one first. Okay, we have 4 digits to place. And then we will consider one by one, right? First of all, the thousands place. How many ways are there to choose my thousands digit? We have 6 digits available, right? I just need to choose either one. So I have 6 choices. Then, oh, not yet, oops. Then we move on to the hundreds place. For the hundreds place, just now we have 6 digits. Do I still have 6 ways to choose the hundreds place now? No, right? Because this time I am making a 4-digit number without repeating digits. That means whatever I have chosen for the first digit, I cannot choose it again for the second digit, right? So let's say I have chosen 7 for my thousands, right? This 6 here means 6 ways, by the way. Okay, if I have chosen 7 for my thousands digit, I can't choose 7 again. And there are 5 choices left, right? So I have 5 ways to choose the hundreds digit. Then once I choose it again, for the tens place, I will have 4 digits left, right? Because I have chosen 2 of them already. So 4 available digits are left. Now that I've chosen the third one, for the remaining one space, I have only 3 digits that I haven't used yet. So I can choose 1 out of 3 of these digits. Okay? Now, once you have considered every digit, how many choices there are, make sure to multiply all the numbers to find the result. Right? 6 times 5 times 4 times 3, that will be equal to 360 ways. So my answer is 360. Okay? So, yeah, very simple. You don't need to list everything out. Just need to consider all the place values and then how many choices are there for each digit, right? Is it repeating? Is it not repeating? And then multiply all of them to find the result. Of course, there may be some special conditions, right? For example, if there's 0, you cannot put 0 at the thousands place. So if there are some special conditions like this, make sure to check the special conditions first. All right? So that's how we attempt question 17. Let's move on to question 19. Question 19 is one of the very interesting questions. Okay, only 21% of you got it correctly. Now, for those who answered it correctly, would you mind sharing what's the answer you get? Right, what's the missing number in the pattern below? Right, so every rectangle has a number, and this rectangle, I will shoot an arrow, then it becomes a cloud, and the number inside it will change. Okay, so what should you do, right? 541, oh, the number becomes smaller. 849, oh, 843, the number becomes bigger, bigger. Wait a second, what's the pattern here, right? I don't think I can solve this using normal mathematics. Now, this is a very useful tip that I want to share with you, right? TASMO will also like to come up with these kind of shenanigans. Whenever you see a multi-digit number as the result, or rather as the starting number, don't just think about it as how many hundred, how many tens, how many ones, right? 541. Don't always think about it as a number as a whole, but rather take a look at each digit separately. Split up the digits, take a look at where do they go and what do you do to them separately, right? Another tip I want to share with you, try to look for some common parts, right? For example, you might have noticed that, wait, there's a 5 here. And there's also a 5 here at the hundreds place, right? Now, remember, we are not looking at them as 3-digit numbers. We are splitting the digits. So this is 5, 4, 1. This is 8, 4, 3, 4, 1, 2, 5, 2, 3, so on and so forth. And likewise, 3, 8, 6. I'm splitting the multi-digit number. And you will notice that, oh, there's a 5 here and there's a 5 here. Also, at the ones place, there's a 6 here, there's a 6 here. So maybe these common parts means I will do something to the 5 on the left and get a digit 6 on the right. What do you think happened? How can 5 become 6? Yes, someone said in the chat, you need to plus 1. Very good. That's what you notice that. Not only 5 plus 1 is equal to 6, right? Remember, when you see a pattern, you need to check it with the other examples as well. 8 plus 1 equals 9. 4 plus 1 equals 5. 3 plus 1 equals 4. Right? So you notice that, hey, this first digit becomes the last digit in this result by adding 1 to it. So definitely, this will be a legitimate pattern, right? It's reasonable, and I can apply it on the last part. 3, 3, 3, the first 3, add 1 to become a 4. Right. Now let's try to look for other common parts. We already figured out what happens to the first digit. Let's look at the second digit, 4. I know, just now it's plus 1, right? And definitely it should be minus 1, right? Possible, because 4 minus 1 is equal to 3. Now, again, when you realize there might be a certain pattern, make sure to check it across all the examples. Now, in the second example, you realize 4 becomes 9. Wait a second, that doesn't make sense, right? So, does this pattern work? It doesn't. So we need to think about other patterns. Okay, so and you realize, now, if I look at the middle number instead, 4 times 2 is 8. Yeah, 4 times 2 is 8. You can do that, right? And now let's look at the other numbers. 1 and 2, 2 and 4. We are all multiplying by 2 to get to the middle digit, right? 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So likewise, what is the middle digit over here? It's simply 3 times 2 equals 6. Okay? And finally, look at the remaining numbers, or rather the remaining digits, right? 1 becomes 3, 3 becomes 9, 2 becomes 6. What are we doing here? What are we doing here? Are we adding or multiplying? Yeah, someone said in the chat, we are multiplying by 3. So likewise, 3 multiplied 3 is 9. So in the last number, 3 multiplied by 3 is 9. And there you get it, the answer, 964. Okay, so sometimes when you see questions like this and you might think, okay, adding the whole number doesn't work, subtracting the whole number doesn't work, makes no sense. Don't worry. Try to split a multi-digit number and look at every part or every digit separately. And then the question might give you a lot of examples. So look for some common parts, right? And try to deduce what is common. Maybe you can find a pattern from that. Right. So this is very useful trick. Okay, so now we have looked at some wacky questions. Let's look at another one which is actually pretty fundamental but asked in a different way. Right, you might look at the question and say, how is this an understanding multiples question? Right, now let's read the question. In a swimming pool, the number of males is 11 less than 6 times of females. Yes. Why? Why 964? Because the left digit becomes the right. Middle digit becomes the middle. Right digit becomes the left. The left digit plus 1 the right digit times 3, right? The middle digit times 2. Then you cross over. Okay? Now let's move on to question 21 again, right? The number of males is 11 less than 6 times of females. And 13 more than 4 times of females. Now, who is 13 more than 4 times of females? Right? What's the subject here? It's the males. So I gave you the number of females and I expressed the number of males in 2 ways. Right? And in particular, you see the word times, right? Remember, teacher Yong Lam always says this. Whenever you see the number of times, right? How many times of? The question you should always ask yourself, what is my 1 unit? So in this question, is males my 1 unit or females of my 1 unit? Right? This means that times, right? Who is my 1 unit? Females is my 1 unit, right? Remember, times, right? Then the 1 unit always appears at the back of the sentence. So females is my 1 unit and males is multiple units. So we will need to draw a bar model to show this relationship. Okay, now females is my 1 unit. So like as usual, write the names, draw the starting line, draw your 1 unit. Now for males, we have 11 less than 6 times. Again, huge reminder, do we do the less first or do the times first? What do we write first? We always write the whole units first. 6 times. So I will draw 6 whole units first. Right. But then it is 11 less. So I will need to cut off 11 from the last unit. 11 less means we don't add extra stuff behind. We cut off a part of the last unit. All right. Now, that is the first part of the question, right? But then the second part also say, the males is also 13 more than 4 times of females. It's the same category, it's the males. So it's the same number, but I express this using a different number of units, right? 13 more than 4 times. So without further ado, 4 times. Let's draw 4 units first. 4 times. We will draw 4 units first. And then you will realize, oh, wait, it's 13 more. Do I still cut away 13 from the last unit if it's 13 more? What does 13 more mean? 13 more means you are going to add an extra 13 after the 4 units. So after the 4 units, you have an extra 13 added behind it. Okay, and finally, right, you realize these 2 amounts are the same. Now let's try to compare them, right? Both of them have 4 units, but then on the first part, I have 2 units, but 11 cut away. On the second expression, I have 13 extra. Now, are these numbers equal? Are they equal? Take note, they are equal because they are referring to the, let me write again, they are equal because they are referring to the same quantity. Both of them are referring to the quantity I have, right? 13. So this part is also what I have. So this part is also 13, right? 1 unit plus this little corner. All together is 13, right? But if I add 11 more, because remember, I cut off the 11 just now. So this is not 2 full units yet. If I add back the 11 at the end, right? 13, add back the 11, I will get 2 full units and they add up to 24, right? Just now, I have 2 units here, but I cut away 11. And I know this is 13, right? According to the next expression. So if I add back the 11, I have 13. If I add back the 11, then I will get 2 units. So then 2 units will be equal to 24, which means now you can find 1 unit. 1 unit will be 24 divided by 2, and that's 12. Now, when you do this, that you get 1 unit, right? Don't get too excited. The question is asking for how many males are there. Don't just give me the answer 12, right? We want to find the number of males, so we need to use either of the scenarios, either the 13 more than 4 times or 11 less than 6 times to find the number of males. So to find the number of males, either 11 less than 6 times. So you draw 6 units first, 6 times 12, and then 11 less, so minus 11. And that's 71. Either it's 71 or 13 more than 4 times, or you start with 4 times first. So 4 units, 1, 2, 3, 4, 4 times 12. Then you add a 13 to it because it's 13 more, right? And whoops, teacher Yong Lam just did a typo, right? This should be 61. Okay, so this answer is 61 as well, which is why when you have the opportunity to check your question, right, definitely double check your answers, double check your calculations, right? Then you will realize mistakes like what I did, and you can save back some marks. Okay, so the answer is 61. Okay, you have 2 ways to calculate the number of males. Yes, the answer is 61. Right, it's confusing. Oh no, but for this question, right, although indeed there's no sum, there's no difference, right? You just need to really understand what's the meaning of times, right? Meaning of multiples, and try to compare 2 ways to express the same number. Okay, so the key point is over here, right? When you have from the second scenario, you get that the extra part is 13 after the 4 units. When you add back 11, you get 2 full units. Okay, that's the key point of this question. All right, ready for the most difficult question of the day? Only 9.5 of you, or 9.5% of you got it correct. And it's matchsticks and numbers. Oh no, right? Now this topic, okay, is indeed very challenging. And the question is asking how many different numbers can be formed using 8 matchsticks. Now, when you see a matchstick problem, most importantly, you always need to remind yourself, how many matchsticks do you need to use for each digit? Right? You need to always ask yourself and refresh your memory on this first. Right? So how many digits, or rather how many matchsticks do I need for each digit? Can you tell me, please? Right, for 0, how many matchsticks do I need? Right. Yes, 6. Right then, 2 for 1, 5. 5 matchsticks again, 4 matchsticks, 5 matchsticks, 6 matchsticks. Then for 7, not 7 matchsticks, 3 matchsticks only. 7 matchsticks for 8, 6 matchsticks for 9. Right, so first of all, have a quick recap on how many matchsticks are needed for each digit. Right, you need to remember this very clearly. Right, this is always the first step you need to do. Then some of you might be forming 2-digit numbers, right, and just counting how many 2-digit numbers are there. But a very important question. Did the question mention how many digits my number should have? Is it asking how many 2-digit numbers or how many 3-digit numbers? Is it asking that? No, it's not, right? Which means it doesn't mention, we do not restrict how many digits your number should have. So you will need to consider all possible numbers of digits, right? So we need to start considering, what about 1-digit number, 2-digit number, 3-digit numbers, etc. Right. So let's start off from a baby question. Do you think I can form a 1-digit number using 8 matchsticks? Do you think I can form a 1-digit number using 8 matchsticks? Is it possible? Definitely not, right? Because even the big boss number 8 uses 7 matchsticks only. So I can't form a 1-digit number using 8 matchsticks. No, right? So now we need to consider 2-digit numbers. Now remember, when you are listing certain 2-digit numbers or 3-digit numbers, have a good habit of writing down the place values, tens and ones, just like how you would do it in question 17, right? Tens and ones. Then let's try every digit and see whether we can match them. For example, can my tens place be 0? Hey, obvious question, right? My highest place value cannot be 0. So I shouldn't start from 0, I should start from 1. Now, the moment I chose 1 as the tens place, I would have already picked 2 matchsticks. Now, I want to use 8 matchsticks in total. That's why my ones digit can only have 6 matchsticks. Now, can you tell me how can I choose my digits for the ones place in this case? My tens place is ones. Who can be my ones place? Right, someone said, I dislike matchstick problem. And yeah, don't worry. With me, right, we review together. Surely you know how to do the next one. Okay, right. Who can I choose as my ones digit here? Right. Oh, some of you said 19, right? I can use 9, correct. Right. What else? What else? 1, 9, right? 2 matchsticks, 6 matchsticks, right? Who else also has 6 matchsticks? 0 and 6, right? So I can use 1 and 0. So 1, 9, or 1 and 0, or 1 and 6. Right, so that's 3 numbers already. Then let's move on. Digit 2 uses 5 matchsticks. That means I have 3 matchsticks left for my ones digit. Does any number has 3 matchsticks? 7, right? The digit 7 uses 3 matchsticks. So 27 is another 2-digit number you can form, right? So you notice my SOP is always starting with a digit, right? For example, digit 3. Start with a digit. Next step, count how many matchsticks it uses. It uses 5. Step 3, then how many matchsticks can I use for my other digit? 8 in total. 8 minus 5 is 3. Step 4, which digit uses 3 matchsticks? 7. Right? So then we found another answer, right? Okay? Then let's move on, right? We still have more to consider. Step 1, what's the next digit you can use for the tens? 4. Step 2, how many matchsticks does digit 4 use? 4 matchsticks. Step 3, that means I need 4 matchsticks for my ones place. Step 4, yeah, the only matchstick digit you can make using 4 matchsticks is the digit 4. So yeah, we formed another number. So likewise, okay, let me go through a bit quickly. Digit 5 uses 5 matchsticks. So how many digits are left for my ones digit? 3 matchsticks are left. So I can only form 7. Now moving on to digit number 6. Step 1, digit number 6. Step 2, 6 matchsticks are used for the tens. Step 3, 8 minus 6. Only 2 matchsticks are left for my ones. Step 4, which digit can only use 2 matchsticks? 1. So 61, I formed another one. Now likewise, 7 as the tens, step 1. Step 2, 3 matchsticks are used. Step 3, 8 minus 3. I can only use 5 matchsticks on my ones place. Which digits have 5 matchsticks? 72, right? 2 or 73, or let's list them out again, 75. Okay, and finally, how about 8? 8 uses 7 matchsticks. That means my ones place has only 1 matchstick. Is it possible? Can I say 81, 1 matchstick? Cannot, okay, my 1 must use 2 matchsticks. So I cannot use 8. So 8 is impossible. So let's consider 9 now. 9 uses 6 matchsticks. So my ones place can only have 2 matchsticks being used on it. So I can use form 91. Okay, and whoa, you will realize, I have found all my 2-digit numbers. There are 12 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But these are only my 2-digit numbers. Don't forget, I still have my 3-digit numbers, right? I still need to consider it. Now, we are considering 3-digit numbers, so hundreds, tens, and ones, we label them. And this time, think about it. I only have 8 matchsticks, and I want to split it between 3 digits. So definitely each digit can only use fewer and fewer matchsticks. In fact, let's think about how can we group 8 matchsticks into 3 groups, right? So key point here, how can we group 8 matchsticks into 3 groups? Now, how can we group them? Maybe, right, I can group them into 2 in a group, 2 in a group, right? I save at the start. That means I will have 4 in another group. Or I can give 2 in a group, 3 in another group, and then 3 in the last group. Now, this involves a bit of number splitting. These are the only 2 ways to split 8 as the sum of 3 numbers, or 3 digits. Oh, yeah. So with that, right, we have some considerations. So first of all, let's say I have groups of 2, 2, and 4, right? So 2 matchsticks, the only digit I can make is 1. 2 matchsticks, the only digit I can make is 1. 4 matchsticks, the only digit I can make is 4. So using 2 ones and 1 4, I can then make some 3-digit numbers. What are they? They are 1, 1, 4, 1, 4, 1. So you can use your dictionary method now. 4, 1, 1. Right, so 3 numbers up to now. Then we also have the 2 plus 3 case, right? 2 in a group, 3 in another group, 3 in the last group. Now, the 2 matchsticks, the only digit I can make is 1. 3 matchsticks, only digit is 7. 3 matchsticks, only digit is 7. So using these 3 digits, what are the numbers I can form now? Now I can form 1, 7, 7, 7, 1, 7, and finally 7, 7, 1, right? So the first case, using 2 1s and 1 4, I can make 3 3-digit numbers. In the second case, 1 1 and 2 7s, I can make another 3 3-digit numbers. So I have made 6 3-digit numbers in total. Now, am I done though? No, we have to keep considering, right? What about my 4-digit numbers? My 4-digit numbers, can I make them? Well, actually, yes, right? 8 matchsticks, if I split it into 4 groups, then every group can have 2 matchsticks, right? Because I need at least 2 matchsticks to form a single digit. So to form 4 digits, every digit needs at least 2 matchsticks. Just nice, I can use up all my 8 matchsticks. So the 4-digit number has thousands, hundreds, tens, and ones. What is the only digit that I can make using 2 matchsticks? Right, it's little 1. So the 4-digit number I can make is 1, 1, 1, 1. That's only one case, right? So I can make only one 4-digit number using 8 matchsticks. Now, I have already used up 8 matchsticks. I don't have any more, right? Which means definitely I can't make 5-digit numbers or longer numbers. So altogether, we have considered all the cases, right? 12 2-digit numbers we can form, 6 3-digit numbers we can form, and finally 1 4-digit number that we can form. So altogether, we have formed 19 2, 3, or 4-digit numbers. Right? Altogether, we can form 19 numbers. Right? So particularly when it comes to forming 2-digit numbers, think about it in terms of the 4 steps, right? What's the 10th digit? How many matchsticks I've used? How many matchsticks are left? What are the digits I can form? When it's a 3-digit number or 4-digit numbers, first think about how many matchsticks you have and how many ways are there to split the matchsticks into 3 or 4 groups, right? 2, 2, 4 or 2, 3, 3. These are the number of matchsticks in each group. Then within each group, try to think what digit can I form using that number of matchsticks. Finally, arrange the digits that you have formed. All right. So with that, let's end off with a slightly easier question, right? Actually, it's easy if I tell you how to do, right? It's not that taxing as matchstick problem, right? This is dice problems, okay? And it will be taught in CO lesson 13, right? So for my CO kids, keep a lookout, okay? So what is special about dice or a die, right? So this is a die. It has 6 faces, and on each of the faces, I have 1, 2, 3, 4, 5, 6 dots respectively, right? And there are 3 pairs of opposite faces, which are your front and your back, right? 4 and 3, left and right, your 1 and your 6, top and bottom, 2 and 5. And what do you notice? Right? You notice that the sum of the number of dots on any 2 opposite sides is 7. Right? That is what the question reminds you at first, right? The sum of the number of dots on any 2 opposite sides of a die is 7, right? 1 plus 6 left and right is 7. Front and back, 3 plus 4 is 7. Top and bottom, 2 and 5 add up to 7 as well. Okay? Now that is the fundamental knowledge of a die. And now Asia is building a solid using 6 dies, 1, 2, 3, 4, 5, 6, which she is gluing together. What is the largest possible number of dots that she can get on the surface of the solid? Right? So in this solid, it's its cuboid, we have 6 faces at the front, likewise 6 faces at the back. 6 faces on the right, 6 faces on the left. And also 1 top face and 1 bottom face, right? Take note, I'm just gluing the dies together. I do not paste them on the ground, so there is still a bottom face. All right. Now, in this case, what's the largest possible number of dots? Now, we can use the relationship that the sum of dots on any 2 opposite sides is 7 to solve this question quickly. Right, let's observe. On the top die, we have a left face and a right face. These 2 faces will definitely add up to 7, right? I don't care, 1, 6, 2, 5, 3, 4. But they are opposite faces, so their dots will definitely add up to 7, right? Now, every dice has its left and right faces exposed at the same time. 7, 7, 7, 7, 7. All right, so this is the last question. Let's hang in tight. Okay, and likewise, the front and the back, okay, they also add up to 7, 7, 7, 7, 7, 7, right? Because the front and the back are both exposed. So we have already found 12 sevens, right? 12 times 7. Then we just need to figure out the top face and the bottom face, right? Now we want the largest possible number of dots. So the top face must have as many dots as possible. That's 6 dots. So we plus a 6. The bottom face, I can also make it to have as many dots as possible, right? Plus 6. Because note, there is no relationship between the two touching faces, right? I don't need the numbers to be the same, etc. So the bottom face, I can have another 6 dots exposed. And that is the total number of dots that you can have outside the surface at most, right? So 12 times 7 is 84. 84 plus 6 plus 6, that is 96. So my answer is 96 dots. All right, and that is it for this question on dice problems, right? Which is the last question of the day, right? So thank you so much for staying with me throughout the entire duration. Hopefully, right, this will be helpful for you in knowing how to solve these problems. Okay, so with that, right, if you have any other questions, feel free to ask them in the group chat or reach out to our teachers. Okay, and I will be posting the full solutions as well as a new sample paper, right, at 7 p.m. later. Okay, and we will meet again at the same timing on next Tuesday for a live analysis for the next sample paper instead, right? Hint, hint, right? The next sample paper will be a past year paper with some adaptations. Okay, and do remember the format of our exam as well. Okay, there are 15 MCQs and 10 short answer questions. Okay, and these are how the marks are assigned. Okay, I will also share with you our answer sheet with sample paper 2 so that you can practice using the answer sheet as well. And with that, that's the end of our live stream today. Thank you so much, and I will see you next week. Goodbye. Okay.好了，好了，好了。我。
OK。